given these two row echelon forms here, we are going to solve a linear system that is actually equivalent to this. Now, since we don't have here specific variables for a linear system, let us consider the variables x sub 1, x sub 2, x sub 3, and so on and so forth. So we are going to take these row echelon forms. These are already row echelon forms after a series of row operations that were applied to a specific matrix, probably that came from the original linear system related to this. So let us consider this. What makes it easier for us to solve linear system after row echelon forms is that we are already given with direct relationships as to variables and their coefficients or their values. These are actually two augmented matrices here. I forgot to specify. These are two augmented matrices here. In short, we could rewrite them. Let's start with the first matrix. We could rewrite this row echelon form in this manner. And let's use x sub 1, x sub 2, and x sub 3 for variables. So you have here x sub 1 minus 3 x sub 2 plus 4 x sub 3 is equal to 7. That's for the first row. The second row, you will have x sub 2. There you have 0 for x sub 1, so we don't need to write it. Plus 2 x sub 3 is equal to 2. Okay, and here comes the first answer, because we already have this relationship here at the bottom. We know that x sub 3 is equal to 5. This is what I mentioned earlier. It's very nice to already answer or solve the linear system if we already have row echelon forms. So that is why we're always tasked to either convert an augmented matrix into the row echelon form using the Gaussian elimination, or the reduced row echelon form using the Gauss-Jordan elimination, in order for us to solve specific linear systems. Now this value will be used to solve x sub 2. So we have here x sub 2 plus twice the value of x sub 3, which is 5, should be equal to 2. So x sub 2 is equal, plus, that's plus, far away. So it's plus 10 is equal to 2. So x sub 2 is equal to negative 8. This is your second variable. And with this 2, we can now solve for the remaining variable x sub 1, because this would be x sub 1 minus 3 times negative 8 for your x sub 2 plus 4 times 5 as your x sub 3 is equal to 7. So x sub 1 plus 24 plus 20 is equal to 7. X sub 1 is 44. Sorry, pardon. Alright, so x sub 1 plus 44 is equal to 7. So x sub 1 is negative 37. So these are the results for the x sub 1, x sub 2, and x sub 3 given this row echelon form. Now for the second, okay, we could also try to come up with the same set of equations here, but we could automatically say that this has no solution. Why? Because you will have here the bottom part of the matrix. You have 0 values for your variable, but you have a value for your coefficient here. But anyway, let's show it and how is it done. So we have here x sub 1 minus 3x sub 2 plus 7x sub 3 is equal to 1. You have x sub 2 plus 4x sub 3 is equal to 0. However, for your last row, as mentioned, you have 0x sub 1, that's 0, 0x sub 2, another 0, 0x sub 3 is also 0. You could say 0 is equal to 1, and it's not, right? So this is not possible. And with this, we have no solution for x sub 1, x sub 2, and x sub 3. So this is how we solve linear systems using already provided row echelon forms. We just need to come up with the direct relationships of the variables to its exact results. There are also some instances where we will be using arbitrary forms of the variables, and that will be for the next video. Thank you for watching.